Hey everybody, it's Brad here, the creator of Expanse, the volumetric skies product for Unity. And today we're going to be talking about how to build a simple weather controller for Expanse. Before we start this video, I have some good news to share. Expanse has been nominated for the 2021 Unity Awards for Best Creative Tool. I can't describe how happy I am. This is really just an amazing thing, and I'm so excited to see how things turn out. I still get a little bit of imposter syndrome when it comes to technical artwork because I'm so young and I have so little experience. I'm 24, and I've really only been doing technical art now for 3-ish years. But to see Unity come out and say Expanse is a really great tool and to nominate it for this award is great validation to see my work up there next to some of the pros like the guys at Gaia Procedural Worlds. But more than a testament to what I've done, I think it's a testament to the community that we've built together. Because what it means is that people are building really, really cool stuff with Expanse. So cool that Unity saw all that stuff and they were like, we think Expanse is a great tool because of all the cool stuff that Expanse is being used in. So I'm forever grateful to all of you guys who are making cool stuff with Expanse and showcasing what it can do with your amazing talent, making it look as good as it ever will. In your amazing games and digital experiences. Come February, there will be a voting round where people can vote for the asset that they think should win. If you think that Expanse is the best creative tool for 2021, then I encourage you to go out and vote. I'll post a link in the description when February rolls around, and I'll also post that same link on the Discord server, which is linked in the description as well. So you might be like, Brad, wait a minute, Expanse is a skies product. Shouldn't there be weather built in? And there's 3 reasons why I didn't include weather in Expanse. Reason number 1 is that if I just had sort of a weather API that was what you interact with and you told the sky you want it to be cloudy, you want it to be rainy, snowy, etc., that removes a lot of the granularity from the authoring process and it makes the tool a lot less powerful. As Expanse is right now, you can animate any parameter exactly how you want to. You can use an animation curve, you could use a script, or you could use a weather controller that's higher level. I wanted to make sure that there was a clean divide between Expanse as a volumetric sky rendering solution and a weather controller implementation that controls Expanse. Reason number 2 is that I want you to be able to use Expanse with different VFX for rain and snow and things like surface wetness. I could provide my own default implementations for these things, but maybe you're looking for a more stylized look to your rain or snow. Maybe you want something very realistic, and if I just gave sort of a one-size-fits-all solution, then you wouldn't really be able to get the look that you want for your game. To sum that up, I want Expanse, when it's integrated into a weather framework, to be compatible with custom VFX. And reason number 3, and you'll see over the course of this tutorial, is that making a weather controller is actually just not that hard. It'll take us about half an hour, maybe an hour. We'll see how long this video turns out. But it's actually not too complicated, and you can customize it to work with your game exactly how you want it to. And I just want to mention before we dive into things that if you do kind of want a weather controller right out of the box that's going to work great with Expanse, you should check out Morpheus 101, aka Eric Hoven's Expanse weather controller. I'll put a link to it in the description. I think it's $20. It's a really great weather controller for Expanse. It has a bunch of cool features, and you should totally take a look at it if you don't want to build your own. So with that all said, let's just get started. All right, here we are in Unity. I am using 2021.2.4 F1, if that means anything to you. And I have a pretty simple scene set up here. It's just, terrain and a camera, and then the Expanse creative sky. The one exception here is that I'm using a procedural cloud volume instead of the creative clouds. It doesn't really matter. You could use either one you want for this part of the tutorial, but I tend to like working with the regular one instead of the creative one. So if you don't understand anything that I just said, you should probably watch this video to get started with Expanse and learn a little bit more about how you can use it. It's only a 15-minute long video, so it's totally worth doing. But anyway, we have our setup here. And so the job of a weather controller is really just to pick out the values that it thinks are the most important for making things look like the weather is changing, and then to animate those values in some way. So we're going to use a pretty classic approach that treats weather as sort of a preset-based system. We're gonna pick a couple different aspects of the sky that we wanna animate, and then we're going to create a scriptable object that stores different values for those presets, and then we are going to write a weather controller script that selects a random preset and interpolates the values in the actual creative sky toward that new preset, and then selects a new one and goes forward, and a new one, and etc. ad infinitum. So it's important for us to pick out which parameters that we want to automate. And I think there's really only two that we need to worry about, at least for now, right? One of them is the fog visibility distance. So, that can change a lot over the course of the day or a couple weeks. Maybe one day it's clear, maybe one day it's very misty, maybe one day you just can't even see anything at all. So fog visibility distance is important. And then the other thing that we're gonna animate is the cloud coverage. And this is just the coverage intensity, and this just controls how many clouds there are in the sky. So we can get a very stormy look by bringing it way up, and have sort of a more dotted look by bringing it down all the way down to a clear day. Great. So the first thing that I'm gonna do is I'm gonna create a new folder. I'm gonna call it weather. And I'm going to create a new script. And I'm going to call this weather state. And let's open it up in Visual Studio Code. So the default thing that it brings up is it automatically creates a mono behavior for us, a game object. We could use mono behaviors for our weather presets, but I think that the more logical thing to use here is a scriptable object. And what a scriptable object is a data container that you can store in your assets folder, and then you can create references to these things on game objects, and they'll automatically be sort of packaged in with your game. It's a great way for managing presets. So what I'm going to do is I'm going to change mono behavior to scriptable object as the base class that it inherits from. And then I'm also going to make sure I type using Expanse, and that'll make sure that we have access to everything in the Expanse namespace. I'm also going to put this in a namespace and call it Expanse Weather Controller, because that is good practice. That way this doesn't conflict with any other thing that you might import that might be called weather state. Expanse Weather Controller. All right, now this is a scriptable object. We don't need start and update methods. We just need to define the variables that we want. And I said before that we're going to use the visibility distance, and I'm going to set that default maybe like 100,000. That's a pretty clear day. And then also the cloud coverage, so mCloud coverage. I'm gonna put that to the default to 0.25 maybe. It's also a good habit to make sure that you set reasonable limits for your parameters. The way that you can do that is you can go here and create, I don't remember what this thing is called. It's like an attribute or a descriptor or something, but you can type that to have a minimum value of 1. And for cloud coverage, we're gonna make that a range between 0 and 1. And then the last thing that we're gonna do is we're going to make sure that we can actually create instances of this scriptable object. And the easiest way to do that is type create asset menu, give it a file name, and then a name for the menu in the hierarchy. This is pretty much just boilerplate from Unity's website. Menu name. Okay, and now if we open up Unity, it'll recompile, but now we should be able to create a folder here called weather states, right click the create menu, and see weather, create weather preset. So I'm gonna call this one cloudy. Maybe I'll copy it and make another one where the coverage is lower and call it sparse. Maybe something like 0.19. And then maybe I'll make another one that's called stormy. and I'll set the fog distance lower in, like 10,000, and I'll set the cloud coverage to something like 0.33 maybe. I don't know. We'll see how that looks. So great, now we have these weather state objects, they're scriptable objects that we can edit and store, but we can't do anything with them, right? We just sort of created these random scriptable objects. We need to create the weather controller that's actually going to consume them. So the next thing to do is right click and create a new script. I'm going to call this weather controller. And now if we go over to Visual Studio, code, we can grab this, and the start and update are actually correct here because we want it to be a mono behavior. I'm going to use the Expanse namespace again and put this in the weather controller namespace. And yeah, so we need to think for a second about what things this actually needs, right? One thing that it needs for sure is that it needs references to the two Expanse components that it's going to be animating, the clouds and the fog, right? So to do that, I'm just going to create public member variables for each of those. I'm going to say public expanse.creativeFog, mfog, and set that to null initially, and public expanse.procedural cloud volume m clouds, and also set that to null. And now you should see if we come into the editor, drink some whiskey. You got to loosen up when you're programming. I can now create a new empty game object, call it weather controller. Just for good practice, I'm going to throw this at the origin. And I can type weather controller, and now we have our script that comes up, and it has fog and clouds and slots for each of these. And what I'm going to do is just open up the Creative Sky, drag the fog over to the fog slot, and drag the clouds over to the cloud spot. Remember that if you're using the creative cloud volume, you'll have to type something like expanse.creativeCloud volume here or whatever, but I'm using the procedural one. So, you know, if you want to follow this tutorial step by step, then just use the procedural cloud volume. But yeah, anyway, so now we can play around with this, right? You know, we could do something like in the update function, we could set the fog visibility distance to 500 and see if that works. Let's hit play. Great, that worked. Look, the fog's rolled in. Or we could set it to time.time. Times, I don't know, like 1,000 maybe will give us something that looks reasonable. Let's check that out. Yeah, look, there you go. Now it's fading out with time because the visibility distance is getting further. You can see it animating here. So you can see already this is powerful. You can just script Expanse in whatever way you want because they're game objects that have positions and attributes, and they live in the scene with all of your other geometry and stuff. But that's not what we're here to do, right? We're here to use these weather states to set different parameters. So what I'm going to do is I'm going to give this thing an array of weather states as a public member variable. Public weather state m states. And now, if we open this up, oh, we have an error. Oh, weather state is not defined. That's interesting. Oh, they're not in the same namespace. This should be Expanse weather controller. All right, now let's try it again. Perfect. Now if we go over to the weather controller, you'll see we have a weather state. Oh, shit. This should be an array. And by the way, I'm gonna leave in every mistake that I make so that you can follow what I'm actually doing and I don't miss anything. This might be kind of messy. We're gonna see. Cool, so now I have an array of weather states and I can add to them, and I can just go over here to our little weather states thing and I can drag them in. So I'm gonna drag in all of our different weather states. Great, so we have our states array now, and now we can actually start to think about what the weather controller is actually gonna do. The model I'm gonna propose is pretty simple. I'm gonna say that we are always going to have a current state and a target state. The current state is the state that we were last in, and the target state is the state that we wanna be in by the end of the current weather transition. And we are going to interpolate between those two states according to some time value. Once we get to the target state, we're gonna randomly select a new target state and make the old target state the current state, and we're gonna do the interpolation process over a period of time again. The only other twist that we're gonna add is that we're gonna allow there to be some downtime between these state transitions. So you could go from clear to stormy in 10 seconds and then have it be stormy for 50 seconds, and then have it go from stormy to cloudy in 10 seconds and have it be cloudy for 50 seconds. That way the weather's not always constantly changing, even though in reality, that's kind of how it works. So I want to block that out in the update function with a couple of really high level sort of function names that will then go in and write. The first thing I'm going to say is if not validate parameters, return. And what this is going to do, this function I imagine is just going to check the fog and the clouds to see if they're null. And if they're null, we're just going to say we can't do anything. So that's going to be up front. Then we are going to check if we're ready for the next weather state by calling a function called readyForNextState. And if we are, we're going to call transitionToNextState. We don't know what these functions are going to do yet, except for what we're calling them. And then finally, we're going to call interpolateParameters. And this is going to, given the current state and the target state, actually interpolate between them and push the update out to the fog and the clouds objects here, components. Great. If we went back to the editor right now, none of this would compile because we need to actually write these functions. So let's start with the validateParameters function because it is by far the easiest. We're gonna make it a bool, return a bool, yes or no, call it validateParameters. Oops. And basically, we're just gonna check if mClouds equals null or mFog equals null. And in this case, I'm gonna print out an error. I'm gonna say debug.log error. I'm gonna say expanse component need to be non-null for weather controller to function. And then I'm gonna return false. Great. The next thing I'm actually gonna do is that I'm gonna assert that we need to always have a target state and a current state that are different from each other. And to have that, we need to make sure that we have at least two states in our states array. And so I'm gonna say if mStates.length is less than 2, I'm gonna say another debug.log error. I'm gonna say weather controller requires 2 or more states to function. I'm gonna put periods at the end of these. You gotta write your error messages like you're writing English. You gotta write your error. That sounds like something that like someone would say grouchily in a code review. All right, and then finally, if we made it through both of these checks, I'm gonna return true, and to indicate that we made it. And by the way, usually you would just return these two booleans ANDed together, and that would tell you what you want. But I want to print informative error messages, so I'm actually just using if statements. For those of you who are going to get on my case for that, because I know that you're out there. So validateParameters is done. Now we can do readyForNextState. So this is going to be another bool, readyForNextState. It's going to tell us if we're ready or not. And basically the way that we're going to tell if we're ready for the next state is we're going to have a notion of how far along we are in interpolating. So I'm going to create a member variable here. I'm going to call this internal state, and I'm going to say private float m interpolation progress. I'm going to start it out at 0. I'm going to make sure that in the start function, I also initialize it to 0, just to be safe. And I'm going to write, this is in the range of 0 to 1. I'm going to call it interpolation between current and target. And then I'm also going to make sure that I have public member variables that say how long the weather transitions are going to be, let people specify. So I'm going to say public float m transition duration. I'm going to set the default to that to something like 5 so we can see it. And public float, I'm going to call this m state duration. And I'm going to write in tooltips, actually, so that people can see this when they hover over, how long weather transitions last in seconds. And here, I'm going to write how long weather states remain still in seconds. Now, you could actually imagine defining this per weather state, per preset. You could say, you could have a variable here that says, how long do I last? Public float m duration or whatever. And then maybe, if you wanted, for instance, storms to not last that long and clear skies to last for a long time, then you could include that in the weather state preset. But for us, we're just going to keep it simple. And every preset is going to last the same amount of time, and transitions between presets are always going to take the same amount of time. Cool. And then actually, I think we're going to need one other thing here, which is we're going to need to keep track of how long it's been since we completed the last transition. And that's going to be so that we can actually implement this sort of like static, like state remaining still thing. Cool. So now we can actually implement the readyForNextState function. And what I'm going to say here is I'm going to return whether m interpolation progress is greater than or equal to 1. So if we have reached the target state, and if we have been at that target state time since last transition for longer than our specified state duration that we want. So I'm just going to put parentheses around these, make it a little bit more readable. Cool. Now, though, you'll notice that, we never changed the interpolation progress, or we never tracked the time since the last transition. So if we actually just went and ran this right now, neither of these things would change. So before we actually check these things, we're also going to take this function as an opportunity to increment both of those things and update them. The interpolation progress, we're going to update according to the interpolation speed, the transition duration. We're going to do delta time divided by the transition duration. And basically this is just going to say, take the time delta in seconds, divide it by the number of seconds that the transition should last, and that'll normalize it to 0 and to 1. And then we're going to say we're going to check, and then we're going to check if the interpolation progress is greater than or equal to 1. And if it is, we are going to then start tracking the time since we arrived at the target state. Delta time. And that will be for this sort of stall before we start the next transition. Great, so there you go. readyForNextState is done. Just in summary, we increment the interpolation progress according to the amount of time that's passed this frame and the duration of the transition. And then if we've reached the target state, we're also going to increment, start recording the time since we reached it. And then to determine if we're ready for the next state, we want to ask, have I reached the target state, and have I waited there for long enough? So Cool, ready for next state is done. We can test it really quickly by commenting out these two lines up here, these two functions we haven't implemented, and typing debug.log transitioning state. Cool. Wow, everything compiled. Could you believe that? I didn't think that was gonna happen. All right, so if this worked, we should see that print out about every 10 seconds. 5 for the transition duration and 5 for the state hold thing. So I'm gonna hit play. Hey, there we go. Uh-oh. It's printing out a lot. The reason for that is that we never reset the interpolation progress or the time since last transition. We're gonna do that in the transition to next state function where it makes sense. We'll sort of transition to the next state and then we'll know we'll have done it and we'll reset those parameters again. So it almost works, but not quite yet. Great, so I'm gonna leave interpolate parameters commented out. Yo, what's up? Which batteries? That we bought. I've never done a programming tutorial before. It's fucking terrible. Programming is so slow, when you type, you have to type at the speed that you want to talk. Right.
Well, you could just.
Cool, so we got ready for next state done. We need to make sure that we actually reset the interpolation progress and the time since last transition on a successful state transition. So we gotta write transition to next state. So let's go down here. This function's void, doesn't return anything, it just does some shit. And the first thing I'm going to do so that we don't forget is I'm going to write reset internal transition state. I'm going to say m interpolation progress equals 0 and m time since last transition equals 0. And now that we have this implemented, actually, I want to I'm gonna put a little print statement up here. I'm gonna say transitioning to next state. And now we should see this actually print out every 10 seconds because we're resetting these two variables. So let's pop back over to Unity. I'm gonna need more whiskey to make it through the rest of this tutorial. And now in 10 seconds, hey, that's better. That's more chill. Look, we got 1. By the way, we could even just go over here and we could probably set this to like 1 and 1, and now it'll start printing out frequently. Yeah, sweet, so we know that works. Transition partner. And I'll leave this print statement so that we can just make sure that this still works. All right, cool, so let's write the rest of this function now. So we need to actually have states in order to transition between them, right? And yeah, we have our states array, but we need to keep track of what the current and what the target states are. The way I'm gonna do that is I'm just gonna use indexes into the array. So I'm just gonna say private int m current state and private int m target state. I'm gonna set these both to -1 first. Just to indicate that they're both invalid, and we'll initialize them to something reasonable in the start function, but we'll do that in a little bit. For now, assume that we're sort of in media res and something looks that they're reasonable values. So the first thing that we got to do here is we have to make sure that we copy the target state back to the current state, because at this point we're transitioning to a new state. We've reached the target state. The target state is now the current state. So I'm gonna write m current state equals m target state. And I'm gonna comment that and say, we've reached the target state. So it's now the current state. And we are ready to choose a new target state. Cool. So now I'm going to say choose a new target state. And here comes the big question. How do we pick a new target state? One thing we could do, we could imagine a simple rule like m target state equals m current state plus 1 modded by the state arrays. length. And this would be, let's actually just try this. Let's just see how it goes. So I'm gonna move this this debug printout down to here. I'm gonna say transition into state, and then m target state. So this will just go through the states in order, basically, and this will work fine. You know, you can see here. It should just say here. Let's just make these a little bit faster. That way we can see this print out quickly. So transition to state 0, state 1, state 2, and now we're going to loop back around to state 0 again. So that's one rule, but that's not very cool, right? I mean, it's not like I go out on Monday and it's cloudy, and then Tuesday is clear, and then next week Monday is also cloudy and Tuesday is clear, and then the next week after that forever. Weather patterns have some structure to them, but they're also, you know, kind of random. Now you could imagine coming up with some really complicated way of choosing these things, maybe a probability distribution, maybe even weighting the likelihood of each one based on some meta season parameter. We're just gonna do something pretty simple that's just one step smarter than this dumb implementation we have right now. We're going to pick the next state randomly. And the way we're gonna do that is we're gonna use something called the system.random object. So I'm going to create one of those right now. I'm gonna say private system.random mRND. Just gonna make a new one. Cool. And I'm going to say m target state is equal to m R&D dot next. This means generate the next random number, and I'm going to say generate a number between 0 and m states dot length, and this is not inclusive, so this is going to put a number between 0 and m states dot length minus 1. So great. And then the last thing that I'm going to do here, this is good, right? But I want to make sure that we don't randomly choose the same state. Again, I want to make sure we always transition to a new state. So I'm going to say while we fucked up and the target state is actually still, our random target state is actually still the same as the current state, just copy paste, try it again. So I'm going to write choose a new target state randomly, sunglasses, and I'm going to say if it's the same as the current state, pick again. And then I'll also write hack. This could time out in a universe of infinite possibility. But the chances of that happening are super, super, super low. Yeah, so you could imagine that this while loop could go forever if we just keep randomly picking the next, the same state. That's not gonna happen. Pseudo-random number generators don't really work that way. If we go back to Unity and we run this again, we should now see, let's lower this again. We should now see it pick a random state. So it starts at state 0, then goes to 1, then goes to 2, then goes to 0, then goes to 2. Okay, then goes to 1. It was random, I promise. It just looked like it wasn't random. Let's try it one more time. 0, 2, cool. 1, all right. And now it's gonna go off in whatever random way it wants to. So, cool. So that actually that works. Our state transitioning actually works. I guess the last thing that we have to do here is implement interpolate parameters. So just as a summary, remember we validated our different components to make sure that all the inputs to the weather controller are valid, right? Before we go about willy-nilly trying to do shit. Then we check if we're ready to transition states. And if we are, we pick a new state and we make the target state the current state and start transitioning toward a new target state. So now the last thing to do is that we know what our two states are. We have a current state and a target state, and we know how far along we are interpolating between the two of them. Now we actually just need to do the interpolation and set those values on our fog and our clouds components. So let's do it. Let's implement interpolate parameters. So void interpolate parameters. So what are we doing? We want to set the visibility distance for the fog. We want to interpolate based on the progress. Now we could write this out in math, but the easiest thing to do, only marginally easier than actually writing it out, is to use the mathf.lerp function. So we'll say m states, our states array, m current state, our current index into the states array, and then the visibility distance that is included in the weather state as our first parameter. Our second parameter is going to be the same thing, but using the target state. And we will blend between these according to m interpolation progress. But remember, we always increment this thing, and it might go longer than the transition duration because we have this sort of buffer period between transitions. So I'm actually going to say float clamped progress, and I'm gonna type mathf dot clamp 01 m interpolation progress. I'm gonna use that clamped one instead. Now we're gonna do the same thing, except instead of the visibility distance, we are going to use the cloud coverage intensity. So m clouds dot m coverage intensity. And here we call this cloud coverage in the weather state. Great, so now, if we didn't fuck anything up, we're good. Let's try it. Let's just give it a go. Wow. 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 Okay, obviously this is transitioning really, really fast because we have it set to 1 second for each one. But if we set it to something like 15 seconds maybe, then it starts to look a little more reasonable. It's still way too fast for an actual game. A game, we'd want to have something like, I don't know, like 6 minutes or something, and then maybe each one of these lasts for two minutes, and it becomes almost sort of imperceptible that the weather is changing. Or maybe not. Maybe you want it to go really fast. I don't give a shit. Do whatever you want. But you probably saw something at the beginning, which is that it looks kind of weird at the beginning. So if we hit play at the beginning, it's sort of nothing's going on, and then nothing's also going on, and then it transitions super fast. This is because we don't actually load any initial states to transition between, right? If you remember, our current state and our target state are initially just -1. In fact, I'm kind of surprised that this is even working, that it's indexing in on -1. So we want to make sure that in start we pick an initial current state and an initial target state. And the way I'm going to do that is I am just going to say m current state. I'm going to pick a random one to start out. I'll say m R&D dot next and 0 m states dot length, and I'll say m target state is going to be another random one, and I'll just make sure again with this little snippet down here that we pick a valid target state. That's not the same. So pick an initial current state, pick a target state that's not the same. Great. So now, if we do this one more time, so now you can see we initially start out with transitioning between those two states. But you know, I still think it's a little bit weird that the first thing that we see is a transition, that it doesn't just hold at the first state. Right, because look, it starts with the transition. So I think instead of starting the interpolation progress at 0, I'll actually just start it at 1. And this will sort of put us in a spot where, you know, the interpolation, we think that we've already interpolated to the target state, and we're just sort of in this hold period before we choose the next one. We started out with something a little more chill. And of course, this is still moving super fast because our defaults are insane. But again, maybe let's say like 30 seconds and have each one last 10. Cool, so now we're transitioning states. You can see that the clouds are coming in. It's getting stormy. This is perhaps when you would start to bring in some rain with some rain VFX. And now we're gonna start to transition again, I guess to state 1, which is the sparse state. So the clouds are gonna back off. Great, and now we are back at sparse. All right, I'm gonna delete this little debug.log line down here just to clean things up. And now we pretty much have the simplest version of our weather controller. The cool thing is that this weather controller runs at basically no cost. All it does is every frame just generates one random number, and then it just sets 2 parameters on 2 of Expanse's components. So it's super cheap, and it's pretty powerful too, because you can come in and you can author tons of different weather states, add them to the controller, and then it'll just cycle through them randomly. And you can define whatever ones you want, really. So even with just 2 parameters, cloud coverage and fog density, we can mimic a whole ton of weather scenarios in a way that's pretty reasonable. So this is pretty cool, I think, and it might get you pretty much all you need, but I think there's some other stuff that we can do that's pretty simple that will make it even cooler. One thing is that under different weather conditions, we see the wind change, right? You know, clouds get faster, they get slower, you know, they move across the sky in different ways. We can control how fast the clouds move across the sky with the movement tab here. And you can see we have ways of controlling each of the different noises that Expanse uses to model the clouds. So for instance, if I set the base velocity to something like 0.005, the clouds will start to move. So I think it would be really cool to add wind to our weather controller. And I'm gonna show you that now that we've got it set up, it's like the easiest thing to do. So all we have to do is go into the weather state, add a new float called mWindStrength. I'm gonna say 0.1 as a default. You could be like a real tryhard here and use kilometers per hour, and that would be kind of cool. I'm just gonna use a value between 0 and 1 and kind of fake it. Set that up. Now go back to the weather controller, and I'm gonna compute the wind strength by interpolating the 2 wind strengths from each state. Wind strength, wind strength. First off, I'm gonna make sure that my clouds are using the velocity parameters in a meaningful way and not just using the offset remaining stationary. So I'm gonna say mclouds.use offset equals false. Now I'm gonna say mclouds.m coverage velocity equals wind strength times, and I'm gonna pick a number here, maybe something like 0.01 as our maximum velocity. That's pretty freaking fast, actually. So let's go 0.005. Let's make the base velocity. And then the last thing to remember here is that actually, these are both vector 2s. These are all vector 2s because it's direction, it's velocity in the x and the y direction. You could make this parameter here a wind direction instead of wind strength, But I'm just gonna make it a wind strength because that's the easiest thing to do right now. So, do what you want to do though. If I was making a real proper one, I would probably make this a direction. That way you could pick a direction for the wind, but yeah. So I'm going to say vector to wind direction equals new vector to 1, 0. And now I'll say wind direction times wind strength, all of these. Best practice here would usually be to define these constants up here, sort of like, private, let's just do this. This is good. This is a good programming lesson for any of those of you who are new to programming. It is good to give everything a name if you can, and to indicate to the compiler that certain things that are never going to change are constant. So I'm going to say private const k coverage velocity k max coverage velocity. And you know what? I'm actually going to call this, I'm going to make this a vector 2, and I'm going to say new vector 2 0.0050. That's what we did, 0.005. Cool. I'm going to say this is max velocities, max coverage, max base velocity, max structure velocity, and max detail velocity. I'm saying max wind velocities. This is going to be 0.01, 0.05, 0.0, 0.1. And now instead down here, we can get rid of this dynamic allocation, and we can get rid of these ugly constants. Sorry to call you ugly, but you are. And detail. Now, cool, and let's make sure these all have F's next to them because C# complains about that kind of thing. All right, what is wrong? Oh no, it must be constant. That's because vector 2s are allocated dynamically. We can't have const vector 2s. Too bad. Oh well. All right, now we can come in here and we can change the wind strength of these presets. So for stormy, I'm gonna set it to like 0.5, I don't know, sparse. I like the idea of the sparse one, the thing's kind of moving a little bit quickly. I'm also gonna up the coverage from where it was last, 0.3. And cloudy, let's just make it nice and keep it nice and slow. Cool. Sweet, so this is just moving fast now. We are really just zipping along with our storm clouds. Maybe even too much, arguably. Yeah, this is too fast, everybody. Let's do, how do we do that for the coverage velocity? Try that out. Wow, yeah, look at that, guys. We did it. All right, guys, well, I was recording this part of the video on my phone and it's about to die, so I think that that's actually gonna put a cap on our tutorial today, for better or for worse. But we just built a weather controller for Expanse, and if you knew some C#, it probably wasn't even that hard. I just wanna underscore the fact that this is a pretty simple weather controller and that Expanse is actually capable of a lot more in terms of complicated weather scenarios. I wanna make a part 2 and maybe even a part 3 for this series where I show you how to use the cloud layer interpolator to interpolate our arbitrary cloud presets that you author offline. This is something that not a lot of cloud systems can do, and I think it's really powerful because it lets you have super different looking clouds like in the real world, all within one session of your game and have them smoothly transition between each other. If you do this tutorial and you're struggling because programming is hard, which no secret it is, come drop by the Expanse Discord and ask me or one of the other people there a question about it, and hopefully we'll be able to help you out and get your weather controller working for you. So I hope to see you stop by for future videos where we'll hang out again and look at more of the cool stuff that Expanse can do. But for now, I'll say thanks for watching, and I hope you have a great day.